Good morning, my name is Dr. K. Ravi Kumar. I am from Sri Sai Institute of Technology, Tamil Nadu. I am going to give a brief introduction about quantum physics. Generally, quantum physics is a subject of interaction between matter and energy, or the study of matter as well as study of energy and their interaction between atomic, subatomic and molecular level. Quantum physics successfully explains the various phenomena such as blackbody radiation and then the temperature dependent properties of semiconductors, and then radioactive phenomena of alpha and beta gamma radiation which is coming from the nucleus. These three things can be explained by the concept of quantum physics. So quantum physics is not only explains this kind of physical phenomena, it also explains how the fundamental devices such as semiconductors, devices such as diode, transistor and ICs, how it works, the atomic and molecular levels. So here I am going to give about the various subdivisions of quantum physics. Particularly, quantum physics is divided into two categories. The first category is quantum theory, and the next one is quantum mechanics. So quantum theory and quantum mechanics are two important parts of quantum physics. The quantum theory explains the particle nature of radiation, and it was discovered by Max Planck in the beginning of 20th century. Later it was explained by various scientists such as Niels Bohr, Albert Einstein and so many scientists. Where quantum mechanics is the wave nature of particle. The fundamental particles such as electron, proton, neutrons, they are not at a particle, they are behave as a waves. These properties was first proposed by 1925 by Louis Victor de Broglie. Later this concept was explained by various scientists, Schrödinger, Drake, so many scientists. Here we are going to discuss about quantum theory and atomic level. So quantum theory, I already explained you that quantum theory is the particle nature of radiation. Radiation means thermal radiation, electromagnetic radiation or whatever it may be. So what is the need of this radiation? I would like to start this by asking a simple question. Let us take an example of a hot stove. And let us take an example of a candle. And you can, we are using it regularly. By using the light of the candle, we could read a textbook, but we cannot cook anything. If you go for the example of a stove, hot stove, by using a hot stove, we can prepare a food, but we cannot read a textbook. So both are giving light as well as heat energy, but someone is giving very high light and very low heat radiation. Something is giving very low heat radiation, very high light radiation. And people have to understand why there is a differences between heat and radiation. This concept is one of the important challenge of beginning of the 20th century. This problem was discussed by so many scientists, and this concept is known as the blackbody radiation. For example, let us take we can decode this problem. What is actually this emitting? It emits the light. And it is not only emitting the light, it is also giving heat energy. If you have a thermometer, if you put it, we can measure the temperature of this. And similarly, we have same kind of three phenomena which is also given by the hot stove. Hot stove also giving some light energy, and it is also giving some heat energy, heat. If you have a thermometer, we could measure what is the temperature here. And from these three parameters, we can come to a conclusion, whereas in this candle, light is very high value whereas heat is very, very low value. When you measure a temperature, obviously temperature will be very, very low value. Similarly, we can find the difference between light. Whereas hot stove gives very low light energy, that means lower value. And what is at H value? It is giving more high heat value, T value. And what about T value? T is also very high. From these three, we could come to a conclusion. Light, when light is increases, heat is getting decreases. When light is increases, temperature is getting decreases. So there is a interrelationship between light, heat and temperature. And if we come to a conclusion, when light is increases, heat is get decreases, in mathematically we could explain it, light is inversely proportional to heat. And we have a separate name for light. Light is represented as wavelength, heat is represented as energy, temperature obviously T is also represented. So what is the conclusion of this? E is inversely proportional to temperature. And one more parameter we have, this is a one relationship between energy and temperature. And if you take two parameters or except E and lambda, and the next parameter is E and T. So from this we could come to a conclusion, when temperature is reduces, heat is also getting reduces. When temperature is increases, heat is also getting increases. That means energy and temperature are directly proportional to each other. So from this we could derive a relationship between E directly proportional to T. And third one is, we have one more parameter, but I will list this here, E and lambda, E and T, and then we have a relationship T and lambda. From these we could come to a conclusion, T is inversely proportional to lambda. So these are the relationship, but these three relationships are explained by the very greatest scientist of big physics. For example, the relationship between the E and lambda was investigated by two greatest scientists, Rayleigh and Jeans. So E equal to 8 pi kT divided by lambda power 4. And this law is known as the Rayleigh-Jeans law. This Rayleigh-Jeans law states that energy is inversely proportional to wavelength. The second law is E is directly proportional to T, but we don't know how many times it can be calculated by the experimental value. That is E equal to sigma times of T power 4. This is one of the standard equation which is called as Boltzmann law. Stephen Boltzmann law. This constant is known as the Stephen constant. And third one is T is inversely proportional to lambda, and it can be combined into a formula T equal to T lambda equal to some constant. That constant is known as the B constant. And this law is Rayleigh-Jeans law, and this law is Stephen Boltzmann law, and this law is known as the Bain's displacement law. These three laws which explains the radiation, temperature, and then wavelength. But there is a drawback in these three equations that we can understand by one more phenomena called black body radiation spectrum. What is actually black body radiation? A black body is an object which emits heat radiation, and it can also absorb the radiation. And people have studied the graph between the black body and black body energy. So it is initially it is increases, after getting a saturated value it is drastically decreasing. And this is what we call as spectrum of black body. From the spectrum of black body, in x-axis wavelength is represented and y-axis energy is represented. And here I missed one more parameter called temperature. It is at particular temperature. When I increase the temperature, something is happening here. It is goes in like this. Still, I increase the temperature, it goes like this and comes like this. That means, when I increase the temperature, something is increasing, something is changing. So here I have a 3 parameter, what I told in this diagram. So here, when temperature is increases, the E maximum value get increasing. Similarly, when I increase the lambda value, initially E energy is getting increasing, and after certain value, it is drastically get decreases. So this part is known as the Rayleigh-Jeans law, which explains the wavelength inversely proportional to E. That means when lambda is increasing, heat drastically decreasing. Here we have a law equal to 8 pi kT lambda power 4. The next one is when temperature is increases, E is increasing. So this law, and this n equal to sigma T power 4. So that's 2 laws are we completed. The next law is nothing but T lambda. Here we have a lambda, we have a T. When lambda is increasing, here I have a peak value, this is called peak lambda, lambda m. This temperature is increasing, the peak value getting decreasing, displacing. That is why it is called as Wien's displacement law. When temperature is increases, the maximum peak value of the lambda get decreases. This is lambda T equal to B. But these 3 laws are explaining a blackbody radiation, but this law is good only for this portion. That means when wavelength is increases, energy will decreasing happens only in the higher wavelength portion. Whereas